So now we started recording. Welcome everyone. Today we're going to talk about linear equations in two variables. Apart from ranting about the fact that Moodle is down and we won't be able to use it, I have prepared some exercises for you here. And these are from the College Board question bank. These are all the questions on the College Board question bank, which are not available in any standardized exam or any past paper or any practice paper or anything of the sort. I do them in this very specific format so that it is portable to Moodle. So if Moodle was up, I would show you how you would do it. You would have the question, you would click check, get feedback, move on to the next question, and then there's a good cycle of feedback. And if you're stuck, I've added a question space on Teams where you can ask questions. So you can always refer to your question with one of the codes that are here. And if you don't want my help, you can just Google the number for the question, and I think you'll find some solution online along with the explanation. So that's now off the way. Why does it say linear equations in one variable? I think that's a mistake. It's not. Must add and write two variables. Oh no. Transcript is in Arabic. This is horrible. You guys. Oh, it doesn't matter. Okay. Okay. Just allow somebody in. And we can now go on. Yes. So, linear equations in two variables, ignore the typo. This is more or less going to be very similar to what we did last time when we were talking about linear functions. So functions which were of the form y equal to mx plus c. So you have a slope and you have a constant that determines the position of the line, so to say. And I would like to start immediately with the questions. So here we have the example of a shipping company which charges a customer $25 to ship some small boxes and some large boxes. So the total sum was $25. He shipped 3 small boxes and some amount of big boxes. So say large. 3 small plus 4 large boxes gives you $25. Now we have some variables, just a moment. A and B. Now A is the number of small boxes. So the number of small boxes is 3. Then you have the price of each small box. Then you have a certain number of large boxes. Then you have the price of the large box. So if B is, we have 25 here. I'm copying this equation. It's for B. It gives 25. And we know that A is the number of small boxes. B is the number of large boxes. Then how many large boxes were shipped? 4. Yes. Yes. So the answer is not too difficult, but it can be very difficult to explain why this is true. So I have been stumbling for the last 2 minutes to get it off the way. We're just comparing our facts here. So if you've ever seen a bill, it's usually the item, the amount, small, you got 3, and large, you got 4, and the subtotal is 25. So this is really what it says. More of a reading question than a math question, but it is what it is. So I would really like to think of this invoice idea, because I think it will be useful as we go on. You have an amount, and then you multiply it, and then you add this amount, and then you multiply it, and then you get a subtotal in the end. Maybe I will let you do the next one. So here we have the number of minutes for Maria, who runs and bikes. So Maria is very, very sporty. And there's a total of something, which is 75. X is number of minutes running. And Y is the number of minutes biking. Then what is X plus Y? No, I wasn't looking at the answer. If I want to write it in the same way, so number of minutes doing what? Running and biking, right? That's really what it is. So running. Hi guys. Okay. Yeah. So it's not too difficult. It's not rocket science. And we are given that this is, on the other hand, we're given that this is equal to 75. Then probably the answer is 75, and it is indeed the number of minutes spent running and biking. So that is also not too difficult. It's just mostly word problems. Maybe I'll change the color. I don't know why I was using red all this time. Then we have this problem. Most of the SAT math word problems are just about interpretation. It's not really about your mathematical ability. So we have 364 paper straws. Maybe I'll just call it P. Each one has an equal length. We use these 364 paper straws to make two things. Make triangles and to make rectangles. Now the triangles and rectangles were constructed so that no two common polygons had a common side. So here it's just making sure that, okay, I won't say what he's making sure of, just ignore that. And maybe we'll talk about it in a moment. Now, if this is the equation, so 364 equal to 3x plus 4y, then probably one of them is triangles and the other one is rectangles, right? Now, just to visually give you the image. So we have straws like this. Many of them. We have 364. But I don't know where you can get 364 straws. If you have them, this very specific problem, maybe to see that different. And so, how many straws does it take to create a triangle? Yeah, okay. Not too difficult. And how many to create a rectangle? Okay, then this takes 4 and this takes 3. Then probably this X is for triangles. And so this many triangles, for each triangle we use 3 straws, and that many rectangles where you use a rectangle for each 4 straws. And now let's look at some of the choices we have. So if 73 triangles were constructed, then 24 rectangles were constructed. So we first agree that X is number of triangles. We agree that Y is the number of rectangles. And now we just need to check which ones work. So it's a combination of the two. What do you want to do?
No, I just wanted to see the event.
Yeah, okay. Well, okay, sure. So let's look at, for example, let's look at the first statement, okay? If you have 73 triangles, then you can make 24 rectangles. Okay, then probably if you have 360, so what this statement is saying that this 364 can make 73 triangles and 24 rectangles. This is what it's really saying. So what do you think? Do you think this is correct? It is.
No.
I don't think it's correct.
X should be the triangles because like there's 3 times X, 3 straws used.
Yeah. So okay, maybe I'll expand on this. So how many straws do you need for each triangle?
3.
So I can just write 73 times 3, right? Good. And then if I want to make 24 rectangles, then how many straws do I need for each? 4. Okay, does this number give us 364? Does it? Probably very lucky. I mean, 24 times 4 is 96, and then you have 73. 73 times 3 is 219. So 219.
I thought it was like, since it was like saying 3X, 3X for triangles and Y for rectangles. Since it said like 3X plus 4Y, I thought Y would be for rectangles and X would be for triangles.
And you are correct. So this is what we're doing. I'm just doing it in a different way. This is what we're saying here. What you just mentioned is exactly what we mean here. This is 100% correct.
We got.
So maybe the idea is to plug in the number of triangles and the number of rectangles, see if it gives you 64. Right? Guys, I know the answer. Like I know the answer. Don't worry about it. I'm just trying to walk you through it. Walk everyone through it, actually. So again, Isiosios, do you agree with me that this is X is the number of triangles and Y is the number of rectangles?
Yeah.
Okay, how many straws would it take you to make, let's say, 73 triangles and 24 rectangles? So if this is 73 and this is 24, can you tell me how many straws you will need? Can anyone tell me? Yes. So
That's 3 times 73 and 4 times 3.
yeah, so 24 times 4, because you have 4 straws for each. For each is the keyword, for each rectangle, and then multiply by 3 for each triangle. Then you get, not sure, I should have my calculator here.
115.
115. But it's not 350.
Is the answer B?
Well, I don't know, but I know that it's not A.
Oh yeah, I know. I thought you were saying A is the correct answer.
Was I?
I know. I thought.
That'll be very bad, you know. Maybe in that case, Javad should be the instructor. Yeah, without me. But you get the idea.
Yeah. No.
Compare-
I did it first, and
We're just reading it.
I was thinking in my mind it's B, and like when you start talking about A, and I thought we were saying A is the correct answer.
No, no way. But you see why it is not the answer, because if you combine,
Yeah.
it takes you 350 something straws, doesn't take you 360 it takes you less. So this is not the answer. Darren, is everything good?
Yep.
Okay, can you tell me why the answer should be B, as pointed out by Flavia?
Because it takes to get 24 triangles.
So how many straws do you need to make 24 triangles?
It's 24 times 4.
Times 4. Make triangles.
Make 24 triangles. Sorry.
If I want to make 24 triangles, how many straws do I need? Triangles.
Oh, to make 24 triangles.
Yes, if I want to make one triangle, how many straws?
I'm sorry, I'm getting confused.
No, don't worry about it.
To make 24 triangles,
Yeah.
you would need
Okay, to make just one triangle, you need how many straws?
3 straws. To make
Okay, good. So one triangle, 3 straws. Now 24 triangles is 24 times 3 straws, because you have 3 for each one of the triangles. Okay, and now similarly, if you want to make 73 rectangles, how many straws do you need? 4 times 73. And I think Flavia has already checked it. So I trust Flavia.
292.
Sorry?
292.
192, I'm not sure. Sure what you mean.
Yeah, I calculate on calculator. 292. 4 by 73.
Oh, he's talking about like 4 times 73 is 200.
Yeah, but then if you add
No, like he did not. He's talking about like 4 times 73 equals 200.
Okay. Thank you, Javad. Thank you. Maybe we'll use you as a calculator. So that's good.
Woohoo!
Yeah. Thank you for your contribution. So this is the answer. And it's simply just because we were able to interpret the problem in the correct way. So in short, the SAT will try to write the problem in the most obscure way possible. You just need to unpack what's going on. You need to do it in proper time, because you won't really have much time to do so. But if you want to run 10 kilometers in 1 hour, you need to run 10 kilometers first. That's what we're trying to do here. So for problem 4, you have a relationship between the number of different pieces of music and the practice session. So y represents the number of, let's say, songs he plays. I mean, if you call a pianist as a song, it's probably not doing him justice, but in modern justice. But just for the sake of simplicity, we have y songs which are played in X minutes. The y songs are played in X minutes. And what's the question asking us? It's asking us to find the number of pieces which will be played in 30 minutes. Someone like to help me do this problem?
Time certain. Yes.
0.1 times 30. The number of songs played in 30 minutes is 0.1 times 30. Does everyone here agree with me on this? Anita, everything good?
Yeah.
You can say no. Say no to saying no. That's a yes.
That's it.
Okay, so you do have problems?
No.
Less than that? Okay, no. Okay. This will never end, right? So basically what it's saying is it takes 10 minutes to make one song. So in 1 minute, he makes 1/10 of a song, which doesn't really make sense because there's no such thing as a 1/10 of a song. But if you want to continuously find this function, then this is what we will do. Okay, so it's the ratio. It's one song for each 10 minutes. So 0.1 is just can be reduced as one.
It's like saying like within the time given for one song, like within the time given, it's like totally 10 songs played. No.
So what this function is telling us is that you have so y songs is equal to 1/10 of
So like for each time, like each time range of time given, like we always play 10 songs.
you want to know how long it will take to play 10 songs?
No, like the equation given, it's basically saying like 10 songs are played for each time given. So like it's the minutes.
So y is the number of pieces of music, which for short we call it song. I'm using a different
Okay.
word for pieces of music. Calling this piece of music a song.
What I'm saying is like no matter what the value of x is, it's always going to be like 10 songs.
You mean 10 times? You mean it's going to be an interval of 10 minutes? So it's going to be a multiple of 10.
Total of 10 songs. So like for example, it's 30-minute row.
Yeah.
So if each song takes like 3 minutes, totally we're gonna play at the end 10 songs. So if the minute changes to, for example, 60 minutes, each song is going to take 6 minutes.
I don't think so.
It's not making the songs, but it's practicing the songs. So like 1/10
So let's
songs.
So let's see if I made a mistake here. It's very likely. So what you're saying is that in 1 hour,
If, for example, yeah, 1 hour, it's 60 minutes, right?
Yes, 1 hour 60 minutes. So you have
0 times 0.1, that is 6.
60. I'll give you 6.
Yeah, so if each song to practice takes 6 minutes, totally at the end, there are like 10 practices. So like no matter what the like you with the value of x is, it's always going to be like 10 practice.
Aha.
Since there is like 1/10 of the time given.
Yeah. Yeah, I see what you mean. So you have a collective interval, you have all of the practice sessions, and then you have a number of pieces of music that are played or practice. So if you have a 10-minute practice session, you would get one song would be practice. So maybe we would like to write down some table for this. Wow, I didn't expect this to be so difficult. It looks easy from the outside.
So easy.
Mhm.
So it's not
No, we're just exploring now. So maybe we'll find something that's nice. So I'd like to write X here and Y. Maybe we'll discover something together. Whenever I'm stuck with the function, I always try to find the values. That's what I try to do. So let's plug in some values. Let's say 10. And maybe I'll write 10 minutes. So X is in minutes.
like what?
So in 10 minutes, how many pieces of music are practiced?
Okay, I get it.
How many pieces of music are practiced?
In 10 minutes is 1.
Okay. And in 20 minutes?
I get it. It's just, I didn't.
Yeah, but it happens, and as long as you have questions, it's fine. I actually thought for a minute that I did something incorrect.
No, you're absolutely right.
No,
But
but
that's just me. Yeah, I get it now.
yeah, it's good. It's good, and it's a good way to inspect. Whenever you're suspectful about something, you can always try to plug in values. So if you have a function, then what you have is really an infinitude of possibilities to discover it. That's how I like to think about it. You can just plug in values on and on and on until you get more familiar with the function. Maybe you get to know each other, sit down for some coffee. But yeah, okay. That was a bad joke. That was a bad joke. Maybe I will decrease the amount of bad jokes for the remaining of the session. But the answer is 3. What do you think, Darren? Do you think it makes sense?
Yes.
Okay, that's good. And now I would not like to do this problem, but I want to say a brief note about it. So maybe this is like a short break for you guys. So I drew this. Yeah, on the laptop. We use a certain language for it, and I drew it myself. It's very nice. And maybe I can show you the code later. So the thing is, to have these stuff on Moodle, I have to rewrite them myself, and that's what I do with the drawings and all of that. So I take huge pride in my drawings, and this is one of them. I also have some more. Maybe we'll take a look at them later. But now I want to jump to the more challenging questions. And when I say challenging, I mean in terms of the college boards. I don't say that the problems are easy or difficult. I'm not judging you. I don't think I'll ever will. But the college board is judging you, so you need to redeem yourself. about this is easy, you know, it's not medium. But anyway, so for this problem, we have a line, and it's defined by a certain slope and a certain y-intercept. We talked last time about what these two things mean. And it says that there's a line J which is perpendicular. And the question is about the slope of the line J. Now, the way you would do this is you would see it for the first time, and then you would redo the same thing basically. So what does it mean to have lines which are perpendicular?
Here, this place would be like -1.
They're what?
Like if you multiply the slope of both lines, it gives us -1.
-1. What do you want to give -1 to?
That's like A1 times A2 gives us -1.
Aha. So you have so you have line K, which has
Slope.
yeah, exactly. So -17 over 3x plus 5, and you would like to call this first slope. You would like to call it M1. I don't think that if I call the slope M, this would be too alien to you because we've used the same notation last time. So that's okay. Now, if you talk about the line J, which is perpendicular, like Isiosius is pointing out to us, it has some equations. So y is equal to, let's say, m2x plus c2. So it has some slope, it has some constant which define it. Talked about what this means. And now we know there's a relation between these two lines. And the relation is that they are perpendicular. And Isiosius is telling us that if he's telling us the following. K and J are perpendicular, then M1 times M2 is equal to -1. Is that correct? Yeah. And this is actually a fact you need to know in order to solve this question. So you need to know the relation between the two lines. So if I tell you two lines are perpendicular, then their slopes have a relation, which is this. Or you can also write, I mean, if you want to, let's say, find the slope of M2, then you can write M2 as -1 over M1. So it's both the additive and the multiplicative identity. I don't want to say this, but it's like you take the additive identity and you multiply it by the multiplicative. Why did I say identity? I mean the inverse. My apologies. The inverse. And you multiply them together. So this is maybe another cue for you to remember. And maybe I'll give an extra note. So if you have two lines, K and J, which are parallel, then what can we say about the slopes of these two lines? And before you answer this question, maybe give me a moment to draw some stuff. I would like to draw maybe I'll draw this line. And if I want this line to have the same slope, I'll just take the same line and maybe I'll move it a bit upwards. This is okay. Okay, that's good. then what can I say about your slopes? So this is your first line. This is your second line. Do their slopes have any similarities or contrasting properties? It should be equal. And this at least makes sense on a conceptual level, because I just took the line and I moved it upwards. And we've talked about how the y-intercept or the constant outputs a different function. So it's like you take this function, this linear function, and you displace it upwards by, let's say, some displacement, and then you get the other line. But in reality, the slope hasn't really changed at all. So that is what we are trying to say here. So another fact for you here is that if k and j are parallel, then m1 is probably equal to m2. And what I want you to do here is I want you to remember this cue. Whenever you have a problem with two lines, and these two lines are parallel, then okay, automatically you have the same slope, but they're probably just displaced differently on the plane. And if you have two lines which are perpendicular, then this is a bit more difficult to remember. And I would actually love to talk about why this is true, why this other relation here is true. But I don't think we'll have time, at least right now, for it. Maybe we can talk about it after class. But these should be the cues. Perpendicular, you flip the slope, and you take the added inverse.
What about the number?
What about what?
The number. The
Sorry?
normal line. Normal to,
The number line.
yeah.
What about it?
Like. Number to J, is it the same as perpendicular?
Yeah, normal. Okay, normal. Or so another word to perpendicular is also normal. Thank you, Flavia. That's another word for perpendicular. This is just vocabulary. So this is a cue for you to remember. And now, with this info, can somebody tell me, now that K and J are perpendicular to each other, can maybe one of you tell me what the slope of J should be? You're saying that it's going to be 3 divided by 17.
Yeah.
Yes, but can you tell me why?
That so -1 divided by -17 divided by 2.
So you multiply it by -1 and you flip a fraction. Yeah, that's really what it is. It's not too difficult. That's how we do it. And maybe afterwards, if you want to talk about it, I would actually love to go over why this is true. But given the time frame, I don't think we'll be able to do it in the meantime, at least. Okay, so that's something for a medium problem. And here we have this setup. So there's this guy Cameron who's driving at an average speed of 60 miles for the first X hours, then driving at 50 miles per hour for the remaining Y hours. Maybe I'll give you 30 seconds to take a look at this. And maybe I'll start drawing some cars. You guys already know me. You know, I'm a very good artist. Art. Camera. And he starts his journey. He goes for 60 miles. And then he completes the journey. So my first question for you is, if this whole journey was 210 miles, then how many miles did he cover in the ground part? So this is all of this is 210 miles. Then what is the ground part? Three.
The question, your question.
My question is about the brown part of the
115.
Yeah.
150. Okay,
Yes.
okay, that's good. Okay, that's good. Now let's even be more accurate here. So this is 60 miles per. Okay, maybe I kind of gave away the answer.
Yeah. I mean, you already completed.
Yeah, I know, but if you want to present the solution, you need to then in a certain way. So 60 miles per hour. And in the problem, how many hours did he spend going at 60 miles per hour? 1 hour, right? So I don't want to say this, but I will say it. So it's like the hours cancel out, and you get 60 miles in the first part. Well, I mean, it's not completely bad to say. Has some sense to it if you go for 60 miles per hour for 1 hour, 60 miles. Then okay, then now you have 150 miles left. So that's the part which I kind of blew away. And he was going at an average speed of how much? So 50 miles per hour times y, which is the number of hours, gives us 150 miles. So what y hours? Maybe I'll even write it like this. Then what is y? Well, the first thing is it's nicely defined, but the hours actually do cancel out. And if 50y is 150, this is from the equation above, then can you tell me what y is going to be? 3. Yes, and this is the answer. Perhaps this is not so difficult for you. So what do you think so far? It's nice. It's just a bit. They speak a lot, right? Lots of words.
X plus 51 is equal to 10.
Yes, It's also something you can do. 60x plus 50y is 210. You can do this if you also think about this invoice kind of thing I was talking about. It's like you have an invoice. We're going with 60 miles per hour for 1 hour. And then you were going for 15 miles per hour for y hours. And the total is 110. So 60 miles per hour times 1 hour gives you this is 60 miles, and 50 times y gives you, well, this gives you 50 times y miles. So 50 times y miles plus 60 is, from this invoice we get that 50 times y plus 60 equal to 210. And from there you can say, yes, I solve for y and I get that y will be equal to 3. So that's also another way to look at it. Thanks to Flavio for this suggestion.
Input to the previous question.
The previous. This question. Don't worry, I'll be uploading the notes.
So like the equation, like we only found the slope of 9k. So it's asking for the line, and so it is asking for line j, but we only find the slope of.
So this is the answer.
So the so if you would read it's saying like line j, but we only, what is it?
Yeah, so
What about like if you want to find like the line?
you want to find the line? Well, you cannot.
So we need like points.
You want to find the exact line, then you cannot, because here's the thing. If I have, let's say this is my line, okay? And all I know is that there's a line which is perpendicular to it. Just believe that this will be perpendicular. I don't know what the y-intercept is. All of these lines are perpendicular to it.
So we need additional points.
If you would like to find the exact line, then you would need an additional point. But for this problem, it is only asking us for the slope. So this is what it is. But nice remark. So if you don't know what the constant is going to be, then you have an infinite class of functions which precisely lie on, I mean, for our example here, lie perpendicular to our original line. So this is a nice visual image to leave you with, at least. But I hope it is clear. And maybe I would like to do one of the quote unquote hard problems. So this is supposed to be a hard problem. This is the graph of there are no graphs whatsoever. This equation is a line. A and K are constants, and the line contains 2 points, which are -2, -6, and 0, and -3. So our question here is, what is the value of K? Maybe I'll give you 1 minute to think about how we can make progress in this, because I really think it's important to get stuck, to try different things and fail them, and try again and make some progress. Maybe I'll give out a hint. Maybe one more hint.
Thank you for the lesson. Have a nice day. Goodbye.
Thank you, Javad. I hope you become the instructor next year.
Thank you very much. I hope so. Bye.
Goodbye. Any progress?
Yeah.
We should. Okay.
No, I'm not expecting the answer. I'm just asking how this problem is going for you.
For the first, it's like in -2 in -2 -6, and also 0 in -3. It's a, I think, like you get two equations. From those two equations, you can write. So,
Yeah, actually. Yeah, I think you understood what I was doing. I don't know if you guys know this, but I was trying to distract you from the solution. And that's what the SAT is going to do. You need to be more verbal.
I found it too.
So I was confusing you basically, but you got it.
but no, I didn't even look at what you were
Oh,
doing.
yeah.
I'm sorry. I know you cannot trust me anymore. No, I'm sorry. But this is
You were right next slopes.
yeah, I mean, but this is not entirely false. I mean, you can try to find the equation of the line, and then you will find out what k is going to be. But that's just too tedious for our purposes. So, what am I talking about precisely? My claim is that two points will give us two equations. And I also claim that two equations and two variables is solvable. For the second one, so this is easy. I will show it to you now. And for the other one, I want to show you why this is true simply. So if we are in two-dimensional plane, I'm talking about the second statement. We are in two-dimensional plane. So you have two equations like this. Okay, that's not. You have a linear equation. You have another linear equation. By the way, it doesn't have to be linear, but you have two linear equations. This is the two-dimensional plane with two variables. Then they intersect at only one point. Let's call them this very specific name. Then this is what's happening. If you have two equations and two variables, then you have one solution. If you have three equations and three variables, then you have one solution. If you have n equations and n variables, then you have one solution. With the caveat, but yes, I mean, so the caveat is really just that the lines cannot be parallel, for example. If they parallel, we don't. This is a good visual image to why this is true. the goal of this very brief discussion is just to build your intuition. It doesn't have anything to do with the problem solving aspect of this exercise. So maybe I'll put this in a nice box and proceed. This is on the side. And now, now back to the first plane. This is plane 1, this is plane 2. For the first one, as Isiosius suggested, I need to plug in the values. So I have 8x plus ky equals 6. And on the left-hand side, I have, not the left-hand side, but let's say on the side, I have the first point, which is -2 and -6. Second point is 0 and -3. And the skill you need to know here is just to know how to plug in. So this is x, and this is y. I hope that's okay. That's good. Then if you plug in, what do you get? Okay, how about I just move x and I write -2, okay, -2a. And for y, I'll remove it and write -6. -2a minus 6k is equal to 6. The second equation tells us that a times 0, this is x, and -3, which is y times k, is equal to 6 as well. Okay, a times 0 is 0. This is just -3k. This is okay. Okay. So okay. And then -3k is 6. Then actually, I don't even think I need the first equation, because the second equation just gives me the answer. -2, yes. In this case, the answer would be -2. Anita, what do you think?
I was right. I was close. I thought like the answer is 2. It's minus.
Yeah.
Mhm.
Next time we'll get. Okay, and it seems like we're just on time to finish. So maybe I'll ask you.
For the value of k, or
So the question asks, yes. So the question asks for the value of k. Okay. Yeah. So we're just on time to finish. And I would like to know if you want to do a couple more problems or you want to call it a day. So if you want to continue. Okay, I mean, it's 10 p.m. I understand. I just had the same issue with the laptop every single time. I set it up late and then I start breaking it. I feel like I'm cursed at this point, but next time I'll get it. So thank you guys for showing up. It means a lot to me. And I'll be here if you have questions. Feel free to just come in.